Welcome to another episode of Lab Wildlife and Other Fantastical University Creatures. We have recently spotted 3 student chemists performing another terrifying experiment. Watch closely as they transfer sufficient, not excess amounts of the copper amine stock solution into the cuvette. Then they transfer dilution 1 made from the copper amine stock solution, dilution 2 made from the dilution 1, and dilution 3 made from dilution 2 to the final cuvette is created from distilled water to use as a reference value for zeroing. Now the student chemist moves from the native habitat, the lab, towards the vast spectrophotometer savanna.
Here, the student chemists start opening the scan software to determine the qualitative data. The student chemists wipe the sides of the distilled water cuvette and place it in the spectrophotometer, ensuring the clean sides cross the photo lens. Closing the lid, they proceed to press the 0 button to ensure that they reset the absorbance baseline in order to create an accurate reading. They remove the water sample and proceed to wipe the sides of the stock solution cuvette, which is the strongest concentration. Place it within the spectrophotometer and close the lid. Then they press the start button and watch as the graph of absorbance versus wavelength is created. It scans all across wavelengths, creates a graph with an absorbance on the y-axis. Then wavelength on the x-axis is created. From this graph, lambda max is recorded as 616 nm. The stock solution cuvette is removed and the lid is closed.
Now the students begin to collect their quantitative data. The students exit out of the scan software and start simple reads. They immediately press setup located on the left margin and enter the lambda max 616 nm. From here, they begin again by wiping the sides of the distilled water cuvette, placing the sample in the spectrophotometer and closing the lid and zeroing the water sample. Then each sample they place within the spectrophotometer after wiping down the sides and press the reads button, and the absorbance is measured and written down. The table to the right shows the concentration and absorbance measures obtained during this experiment. Finally, all solutions are disposed of down the sink. The apparatus is washed and the area is cleaned. Now it's time for calculations. De Beer's law states that A is equal to ELC, where A is the absorbance, which is taken from the simple reads of the spectrophotometer. E is the molar extinction coefficient, which is the measure of how strong the light absorbs, and is calculated as the change in absorbance over the change in the concentration, or otherwise known as the gradient of the concentration absorbance graph. L is the path of the cuvette, the path length, which is the cuvette, which is 1 centimeter, and C is the measure of concentration, which can be determined through the equation M1V1 equals M2V2 table if the concentration of the stock solution is unknown. From the plotted graph, it is easy to identify that the relationship between absorbance and concentration is linear. If the spectrophotometer was not zeroed prior to the simple reads, then the absorbance would be higher, as they would increase absorbance measures from the cuvette and the water. So instead of having an absorbance of 0.915 for the stock solution, it could be something like 1.5.
This concludes the season finale of Lab Wildlife. Join us next season, hopefully if our student chemists survive the daunting task.